Imagine this. Right now, something from another star system is moving through our solar system, doing things that by all logic shouldn't even be possible. Sounds like science fiction, right? It's not. Some studies suggest that interstellar visitors like this pass through our cosmic neighborhood as often as 7 times a year. But this one is different. It's called 3I Atlas, and whatever it's doing has left NASA scientists genuinely baffled. We're talking about behavior that breaks the very laws of physics. When the first readings came in, researchers thought their instruments had malfunctioned. But every check, every test confirmed everything was working perfectly. Which means what we are seeing might be something far bigger than just another icy rock drifting in from deep space. And that's what makes this so unnerving. Even veteran physicists admit this case might change how we understand the universe itself. For decades, science has dismissed discoveries that didn't fit the models, but with 3I Atlas, there's no way to ignore what's happening. The data keeps coming, and every new detail only deepens the mystery. Even the most conservative astronomers are now asking questions that once belonged only in science fiction. And the strangest part? The official reports barely scratch the surface of what's really going on. To see how we got here, we have to rewind. On September 13th, 2024, astronomers using the Atlas survey in Hawaii noticed something unusual entering the solar system: a traveler from interstellar space. At first, it looked harmless, maybe another oddball like Oumuamua, that strange cigar-shaped object from 2017, or Borisov, the more typical interstellar comet spotted in 2019. It was soon catalogued as 3I Atlas, the third confirmed visitor from beyond our solar system. But within weeks, it became clear this wasn't just another comet. It was doing things no natural object should. When 3I Atlas passed Mars on October 3, 2024, at a distance of about 18 million miles, nearly every major spacecraft watching the red planet turned its gaze toward it. NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express and Trace Gas Orbiter, even China's Tianwen-1. Their goal was simple: measure how Mars's gravity bent the object's path. That's basic physics, something Isaac Newton could have calculated centuries ago. But what they found didn't make sense. The gravitational pull, the tiny deflection every massive object should cause, was almost non-existent. Based on its apparent size, somewhere between 3 and 29 meters across, it should have weighed around 33 billion tons. That's the mass of more than 5,000 Great Pyramids of Giza combined. An object that heavy should have tugged noticeably on Mars, maybe even nudged its moons, or shifted our spacecraft orbits slightly. Instead, nothing. Its gravity was effectively zero. Think about that for a second. This isn't a rounding error. This is a direct challenge to Einstein's theory of general relativity, the rulebook that says mass bends spacetime. For something visible and that large to have no detectable gravity means it's either almost weightless or it's not what it appears to be at all. So what are we actually looking at? An object? A projection? Something made of material that doesn't obey gravity the way everything else does? For astrophysicists, that's like watching a cannonball and a balloon fall at the same speed. It breaks every rule we know about mass and motion. That leaves us with two deeply unsettling possibilities. One, 3I Atlas is made of some unknown ultra-light material, lighter than any substance ever recorded, lighter even than aerogel, something that shouldn't exist in nature. Or two, it's mostly empty inside, a shell disguised as a solid body. And here's the problem: holocomets don't exist in nature. They can't. Comets form through accretion, where dust and ice clump together over billions of years, pulled by their own gravity until they become dense, solid bodies. Like packing snow into a snowball, it gets firmer and heavier the more you compress it. Natural formation never creates hollow shapes. If you sliced an ordinary comet open, you'd see the same mix of ice and dust from its core to its crust. But 3I Atlas doesn't follow that rule. It breaks it, which leaves only one explanation that fits the evidence: artificiality. Something built it. A hollow structure in space implies design, engineering, a purpose. Maybe it's a vessel, maybe a probe, maybe a signal. Whatever it is, it forces us to question our biggest assumption, that every interstellar visitor is a natural rock or comet. 3I Atlas doesn't fit that mold. It demands a new category, one where natural is no longer the default answer. Harvard astrophysicist Avi Loeb has been studying how it spins, or rather, how oddly it spins. For an object of its apparent size, the rotation is far too slow. For something of that size, its spin shouldn't be that steady. The only way the numbers make sense is if a massive portion of its interior is missing, as if the whole thing were hollow inside. And that's just the beginning of what doesn't add up. The next anomaly is even stranger. 3I Atlas isn't speeding up as it nears the sun. It's slowing down. And that, by every rule of physics we know, should be impossible. Here's why that matters. When a normal comet gets close to the sun, heat vaporizes the frozen gases on its surface. They jet outward like tiny rocket thrusters, always pushing the comet away from the sun and making it move faster. It's simple Newtonian motion, and it's been observed for centuries. Oumuamua back in 2017 was weird because it accelerated too, but without showing any visible jets. That mystery sparked years of debate. But even then, it sped up, not the other way around. 3I Atlas is doing the opposite. Between September 23rd and 26th, 2024, data from the James Webb Space Telescope, ground-based radar, and Doppler readings from Martian orbiters all matched. Its velocity dropped from 42.4 to 42.2 kilometers per second. That might sound tiny, but in orbital mechanics, that's enormous. Random measurement errors bounce around. This was consistent, directional, and confirmed by multiple independent instruments. There is no known natural process that can apply a braking force to an object moving that fast through the vacuum of space. Solar radiation pushes objects outward, it doesn't slow them down. Outgassing jets make them accelerate, never stop. And gravity? It pulls inward, making them move faster. So what on Earth, or off it, could possibly be causing this? 3 theories are being whispered about, each more mind-bending than the last. The first suggests some kind of solar sail, but one working in reverse. Instead of catching sunlight to speed away from the sun, imagine a massive reflective sheet, angled just right, to resist that push, turning solar pressure into drag, like a parachute made of light. For that to work, the object would need an incredibly precise, steady orientation, perfectly aligned against the incoming photons. And here's where it gets weird. Spectroscopic data shows that 3I Atlas is unusually reflective, mirror-like, unlike the dark, dusty surface of any known comet. But natural bodies don't hold position like that. They tumble uncontrollably through space. Yet this one rotates with near mechanical stability, so precise observers have called it clockwork. Think about that. An object traveling for possibly millions of years through interstellar space, hit by micrometeorites, pulled by countless gravitational fields, and still maintaining perfect spin stability? That's like finding a spinning top standing upright in the middle of a hurricane. It's not random, it's controlled, like spacecraft attitude control. It isn't just rotating, it's managing its rotation. The second possibility is even more advanced, that it's moving with some kind of active propulsion we can't detect. Maybe an electromagnetic drive producing thrust without exhaust, or an ion engine so subtle that its emissions fall below our detection limits. Observers have even noted a faint green glow around its core, possibly ionized plasma, maybe the byproduct of a system we don't yet understand. But that idea runs into a huge problem. To slow down a body that size would require an enormous energy source, one powerful enough to run for ages in the frozen emptiness between stars. No natural power source we know of could do that. And then comes the third and perhaps most unsettling theory. What if 3i Atlas is using gravity itself, deliberately timing close passes around planets to change its speed and course, the same way Whistling shot probes around worlds? During its October 3rd flyby of Mars, its velocity changed just enough to suggest intentional maneuvering. And its future path? It's set to pass close to Venus in early 2025, then swing near Jupiter in March 2026. Those alignments aren't random. Statistically, the odds of such a sequence happening by pure chance are less than 1 in 50,000, about the same as flipping a coin and landing on heads 15 times in a row. Mathematically possible, sure, but you'd start to suspect something or someone was controlling the outcome. Put it all together, and one conclusion becomes hard to avoid. 3i Atlas isn't drifting, it's steering. It's not a lost traveler, it's slowing down, as if preparing to stay within our solar system longer than expected, for reasons we can only guess at. And then there's the silence. After its close pass by Mars on October 3rd, the flood of data everyone expected, from NASA, from ESA, never arrived. NASA blamed the sudden government shutdown that began just 2 days before the flyby, conveniently freezing all official communication right when the world was watching. The European Space Agency says its data is still being processed, and China's space agency, the one that usually shares images within days, has offered no official comment on what Tianwen-1 saw. We've seen this pattern before. When Oumuamua swept through in 2017, key radar and spectroscopic results stayed out of view for months. When Borisov arrived in 2019, the same delays followed. Now with 3i Atlas, the same silence repeats again and again in an age when information moves at light speed. Silence becomes its own message, loud, deliberate, impossible to miss. Here's what keeps me up at night. On October 29, 2024, 3i Atlas hit perihelion, its closest point to the Sun, at about 1.36 astronomical units. That placed it just inside Mars's orbit, where the heat and radiation are at their fiercest. And it happened on the far side of the Sun. From Earth, we were blind. Our best telescopes had to stare straight into solar glare, giving us an observing blackout that lasted for weeks. If anything significant happened, it happened then, perfectly hidden. A natural comet at perihelion usually does one of two things. It cracks apart under brutal thermal stress, or it grows a huge shining tail as its volatile ices boil into space. But when 3i Atlas came back into view in late November 2024, it looked unchanged. No fractures, no debris, no signs of failure. For something supposedly made of loosely packed ice and dust, that kind of toughness is astonishing. Comets are fragile, cosmic snowballs that break easily when they heat up. A hollow comet racing at over 124,000 miles per hour should have torn itself apart from structural instability alone, especially in that solar furnace. Yet it didn't. It survived. Harvard's Avi Loeb has floated an even bolder idea. In a recent paper, he suggests 3I Atlas could be a transport, a parent ship, carrying smaller payloads inside its hollow core. He compares it to a dandelion scattering seeds, releasing probes at the most opportune moments during its run through our system. And perihelion, the exact window when we couldn't see a thing, would have been the perfect time to let them go. Think through what that would mean. If smaller objects were released during that blackout, they could now be moving quietly through the solar system, following paths we can't forecast, with purposes we can't guess. The Galileo project, which Professor Loeb leads, is now scanning the sky for fresh anomalies. If new unknowns begin to show up, if sensors start flagging events that don't fit the playbook, and the timing lines up with 3I Atlas's perihelion, that correlation will be hard to dismiss. So where does that leave us? We're staring at an interstellar visitor that refuses to follow the rules. It looks hollow when it should be solid. It slows down when it should speed up. Its path seems guided when it should be random. Its toughness hints at engineering when it should be brittle. And the very institutions tasked with watching the sky keep falling quiet at the precise moments we most need clarity. As a physicist, I don't see a crisis. I see an invitation. Every anomaly is a message. Every deviation is a question we haven't learned to ask. 3I Atlas will keep moving through our neighborhood through 2025 and beyond. It passed within 167 million miles of Earth on December 19th, 2024. In March of 2026, it is set for a close encounter with Jupiter, another chance for a gravitational nudge, another opportunity for a deliberate course correction. The European Space Agency's JUICE mission will be there to watch. We stand on the edge of a real-time confirmation or refutation of something extraordinary. Oumuamua slipped away too fast to study properly. 3I Atlas is giving us months, maybe years, to gather data and understand what we are actually looking at. Whether it turns out to be a rare natural phenomenon or something far more profound, it has already done something remarkable. It has forced us to confront possibilities we usually lock inside fiction. The universe doesn't owe us neat answers or tidy models. Now and then, it sends a messenger through our backyard to remind us that the biggest discoveries don't arrive as conclusions. They arrive as better questions, the kind that push us into places we never thought we'd explore. Maybe that's the true role of 3I Atlas. Not an ending, but a beginning. The first page of a larger conversation, written not in our language, but in the quiet choreography of worlds moving across an endless stage. So what's the takeaway for us down here? Never stop asking. The story of 3I Atlas shows that the real barrier to discovery isn't the distance between stars, it's the cage of our own certainty. Stay curious. Test the official narrative. Accept that we may only now be learning where we actually stand in the cosmos. This mystery is still unfolding, and will keep following every turn. What do you think 3I Atlas is? A natural outlier that will force us to rethink physics? Or the first clear sign that we are not alone? Share your theory in the comments. And if you want to keep up with this and other riddles the universe throws our way, hit subscribe and turn on notifications. You won't want to miss what happens.